Okay, we've got a whole heap of things going on here. We've got calculus, maximums, minimums, differentiation, integration, I think a bit of factor theorem, graph sketching, and a whole host of things all working together. Let's get started. What we've got is, first question, find f of x, and we have f dash, we've got the differential, which means that what we need to do is we need to integrate this thing to get back. So integrate with respect to x, and all we got to do, bump those powers and then divide by bump the power and 3 divided 3, bump the power, divide by 3x, and of course the problem with integration is we get a plus c, which is why they've given us that thing there, and that's going to tell us what plus c is. This tells us if 0 goes in, 4 comes out, so let's put 0 in, 0 minus 0 minus 0 plus 0 plus c, and the answer is 4, which is telling us that c has got to be 4, which is telling us then that f of x has got to be 1/4 x to the power 4 minus x cubed minus half x squared, half x squared plus 3x plus 4. Done. Okay, let's quickly move on. Minimum points. In fact, let's go blue on this one. Minimum. Things about minimum points are that for a minimum point, f dash x would be 0, but also the second differential would be greater than 0. That tells me I've got a minimum. Now I've got this thing already, f dashed of x. I've got to differentiate again, so let me just check out f double dash of x is what I'm trying to say there. Let's differentiate again so that I can use that. Differentiate, multiply, and then take 1 off the power. There's f dashed of x, and now all we've got to do is check for these. So f dashed at -1, and that's going to give me -1 minus 3 plus 1 plus 3 equals 0. That's good. And f double dashed at -1 put in here is 3 plus 6 minus 1, and that's clearly greater than 0. Minimum point, and we need all this to give us our answer. Let's check for 3, and I'm sure you can figure this one out. 27 minus 27 minus 3 plus 3 equals 0, so it tells us we've got maximum or minimum. And f double dashed at 3, and where are we? Here. So what's that? 27 minus 18 minus 1, still greater than 0. Another minimum, and both work. So that's 6 marks. Done. A maximum. Now this one, strangely, what's going on here. This is the best way. There's a number of ways to do it, but one of the best ways to do this is to use the factor theorem, because what we're looking for here is we're looking for values of f dashed of x equals 0. Now we already know 2 zeros because we've been given those 2 minimums. We've got to find the third. And if we're careful about this, we can be quite sneaky, save ourselves a bit of time. Factor theorem tells us if we've got zeros, we know brackets. We know this is a 0. So x plus 1 must be a bracket. This is a 0. So x minus 3 must be a bracket. Now if we look at this, we know we've got x times x. The only place that comes from is there to give us an x cubed. The other thing to look at is this. Minus 3. Now we've already got a 1 times minus 3. Multiply again. I reckon we need to multiply by minus 1 to give us that combination to give us plus 3. Only thing that it can work, so let's check that that is my third bracket and it will give me 0. X equals 1 is going to 0 that bracket, so let's check. F dash at 1, put it in, 1 minus 3 minus 1 plus 3 equals 0, so that checks. And second differential at 1, second differential which I've missed now, I've written it down, lost it. I'm going to let you check that one, but you will find the second differential, which I'm sure you've got written down, is less than 0, and that will imply we've got a maximum point. And if that checks out, then the factor theorem has given us the bracket, has allowed us to throw it in the formulas, and we've got our maximum point. And finally, state the range of values. I reckon for this, the easiest way is simply to sketch the curve. If we look at f dash of x on a graph, we know it zeros in 3 places, at -1, at 1, and at 3. And it's cubic, and therefore it's got this general shape, so it looks something like this. And if we want to ask ourselves, where is that greater than 0? Well, I'm pretty sure if I look at this, it's greater than 0 there, and it's greater than 0 there, which means the bits that I want for x are that bit, and then onwards there. So, greater than 0, well, I reckon x between -1 and 1, or x greater than 3. And those will give me greater than 0. And that's our question done.